morning, everyone. Welcome back. So, point me to where we should get started from. I reckon it must be Deadlock. Is this so? Just send me a quick message to let me know. Is it this one? So if we start Deadlock today, then that means Monday we will finish. So from Wednesday, it shall be all yours. It shall be your time. Okay, there's a message there. Let me check. Why didn't it show up? And well, my lab 1.4 is not graded. Wing Kim Tak. Okay, let me check why it was not graded. Let me check. So doing it in the rush. May have missed. Wing. You are this book is gone. Wait a minute. Your group is this one, right? Wing Kim Tak. Wing Kim Tak. Where did you submit it? Wait a minute. The point is, where exactly did you submit? I will show you your screen. Wait a minute. Friday, 8th October. This is, I think, a classic problem. Are you a repeat student? I mean, is it the second time you are taking it? Kim Tak, you're taking this course for the first time or the second time? The first time. Okay, so there you are. Where is your name? I couldn't find it. This is your group, as you can see at the top, AI 1604, right? And these are the names: Vinfolk, Kwok Hum, Din Min, Dien Phuc, Min Kong, Wang Hui, Huayan, Hu Huang, Dan Hom, Long Ha, Liam Chuk, Duc Huang, Wak Hui, Xuan Huang, Nhat Min, Dui Bao, Ngoc Phat, Chi Khang, Hui Min. And it's done. There's nothing, no other page. So where did you submit it? Your file is not here. Where did you submit? Your name has a difference from each other. I mean, what do you mean by differences each other? I didn't really get it. What kind of difference you mean? Your file is not available with the submission on LMS. You are not even there. I think you enrolled in the wrong course. Even if you don't submit, you should have appeared right here in this list. As I scroll down, you can see that you didn't even enroll in the course. Where is your name? Okay, you can share your screen. All right, let me see. Let's stop it. You share your screen. Okay, can you Just wait a minute. OSG202 send me labs 1 to 4 submission. That's okay, but why it doesn't show up? Where did you submit? But did you submit it? The point is, yes, why your name is not in the group? I mean, wait a minute. It's a serious case. If you are a first timer, it happens with the repeat students. That's why I asked you that there's kind of technicalities involved here that where you have to take, you have to go to them and ask them for permission for removal. But all participants, let me see. No, Kim Tak, it's nowhere to be seen. Because I changed my name. It's not in the group AI1604. So what is going on there? How can you change your name? Changing name has nothing to do, as long as your email ID is okay. Okay, I remove the filter and still I don't see it. THACH. No, nothing. You can see on my screen. I'm taking it from everyone. It's a serious issue because, wait a minute. You can see now it is all participants, as you can see right here, all participants. Okay? And even I type with your name, nothing there. Hey, wait a minute. Did you submitted on the new interface, right? On this interface, or you use the old one? I don't know whether it's still active or not. Did you use the new interface? Because there was an old LMS there. Did you submit in the old LMS or the new LMS? Can you choose filter by letter N? Letter N. Okay. So N is there are a lot. 186 N. Give me the name that you have used. Or you send me your email. I will search with the email because that's easy. Email doesn't change. You can change probably your name, but you can't change the email. Okay, let me try with the email. Strange. No, nothing. Nothing. You can see I'm searching with your email. The point is, it's not about the labs. It's about that you have taken the quiz. Probably, let me check your quiz. It seems you are not even enrolled in this course. So in that case, all your grades will be zero, because if I don't see it right here, then I have no perception that I only grade the ones who show up right here on LMS. Let me see progress test. All participants.
Teacher, you maybe make a mistake on this email. So I sent another in the chat box.
Wait a minute, let me check right here. No, even with your new one, there's no match. You see, you're not even. Did you do your quiz? Where? No, it's not. Doesn't show up. What are you doing? Oh my! Your quiz is not here. Check. First of all, you must be right here in this group, AI 1604, because that's the way the scores will be downloaded. And where is your name? Where is your name? Nowhere. So you immediately get in touch with the IT guys and tell them what exactly you did, or you changed your name or something, because it's not showing up right here. Can you share the screen once more? I need to check. But if you join the wrong group, then at least it should AI 1603. Are you sure? Let me see. Where? You are not even with a 1603. This is 1603. You are not even there. Wait a minute. You are not even in 1603. That's my screen. So can you share your screen? Can you share your screen once more? What is that? Participants. So can you scroll up? Where is your name? Your name is not there either. Can you send? Can you share the screen of your submission? Can you share the screen of your submission? Okay. Can you scroll up the top? Wait a minute. Where's G202 send me? Is that what the page looks like? Okay. Yeah, it apparently okay, but what's going on here? Get in touch with the IT guys because we just have one more week here. I mean, after one more week, I will download all the scores and then I'll submit, and you will not have any grade. That's risky, as you can see that we can't even find you anywhere. You are not even in 1603. I mean, for the lab, I can only give you the score once you are there. Let me see the participants. All the participants are here. But even if you filter, I don't think so. Ah, here. No groups. Groups, no groups. Hey, wait a minute. Where did you submit? Did you see that on my screen? Now let me share my screen. Oh dear me. See, here you are. No group. No group. I think when you can you edit it? Okay, let me see if I can edit. Okay, I think I can assign you. Wait a minute. I can do it from here. I've never done it before.
Teacher, our class AI 1604.
Let me see if it works or not. No, it doesn't work. So I can't assign.
Select it, the box, and enroll, and then enroll.
Okay, I have to click right here probably, right?
Yes.
And enroll. They're asking me select users, no selection, too many users to show. So what should I write here? This one, no suggestion.
Hmm.
No more. Users, all grades if possible. Starting from November. The problem is that what's your ID number? AC? Can you tell me your ID number? Okay, there we are. I think that will help, hopefully. Your ID. Should be a serious issue. But still no group. Why? Okay. There's something there. You set enrollment, send a message, add a new note. Okay. Sorry for the delay, but this is an important issue. What happened now? Still no group. I'm totally confused. Yeah, I've been added to 2 times now. I even don't know whether I'm doing it right or wrong because I've never done it before. Didn't have to. Well, leave it. So can you do one thing? Just things got messed up. So what you can do still is better than you have identified right now. Unenroll. Okay. Then re-enroll. I will give you extension 24 hours to submit lab and 24 hours for quiz. In fact, for quiz, you don't have to worry because I will open the quiz. Some of your friends didn't do the quiz, so I usually open the quiz in week 9 or week 10. I will open the quiz once more. So for lab, first you unenroll. Get out from whatever you did. You already have the file, so then re-enroll to the correct group, and your group ID is still the same. AI 60, what's that? 160, AI 1604. 1604. That is the password. Okay? Use the password to enroll in the right group. And then after enrolling, you let me know. You will have to alert me, send me an email. And I will give you 24 hours on lab, 24 hours on lab submission. I'll grant an extension for 24 hours. And you just go there and submit it. Is it okay? Because you need to be on that page. Otherwise, your presentation marks, your all scores will be gone. I will not get anything. Why you can't unenroll? Okay, so let me try to do it. Unenroll. Now you are unenrolled, right? So it seems that I could easily. You are now unenrolled. Can you enroll again? Now you're still active. Ah, you are already in the group. Did you enroll just now? 12 seconds. Okay. Good. OSG 202. Progress test, don't worry. Progress test I will open to at the end and then you can take it. One ungraded. Your files are ready. So 29th October, today midnight. Is that okay? You got an extension? So go there and drop it there. Is it okay now? You submitted it already. Let me check whether I got your submission or not. Oh, dear me. Okay, done. I will check it later. For quiz, don't worry, but if you come to the class every day, you will get to know probably in week 9 or week 10. Usually in the week 9, because week 9 I open the other 2 quizzes. So at the same time, I will open the quiz for a short period of time. For those who missed it for whatever reason, you can take it. If you have already taken the quiz, you can't retake, but only those who haven't taken it, they can take it. All right, problem solved. I will check it later. Yeah, well, how could you enroll without getting into any group? That's my question. Is it your fault or the developer's fault that they let you in without any group? That's my question. Whose fault is it? You must be at least in one group to get enrolled. Okay, and don't change your name or anything. All right, we lost a considerable amount of time here dealing with that, but this was urgent. So we go back and at least get started without further delay. So what did we do in the last class? If anyone can remind me, what did we do? Did we give you any introduction about this deadlock, or we didn't start it at all? Did we give any introduction to this one? Okay, this one is gone. All right. So I get started. So what the first question is, why did luck happen? What's happening here? Oh my. Really? It works in that way. Okay. Let me use another color. So the first place is, why deadlock happens. The reason of deadlock is this. We have process and we have resource. The story of your computer is a story of interaction between processes and resources. There are 2 scenarios. One scenario is what we call the request scenario. In the request scenario, as we guess, in the request scenario, we have multiple processes trying to acquire multiple resources. In other words, anyone can actually ask for anything. What we mean, this scenario is a little bit complex and messy. Any process at any point of time can ask for any resource. Okay? In other words, a resource can be requested by multiple processes at the same time, while any process can request for any number of resources at any time. So literally, it is many-to-many sort of relationship. But when we go to the usage scenario, it's highly restricted. One process one resource rather, can only be used by one process. Well, one process at the same point of time can use multiple resources, but two processes won't be allowed to hold on the same resource. If that happens, that will be deadlocked. So the resources are the most important. And that's where the word mutual exclusion, if you can still remember, we found it earlier. We talk about mutual exclusion. That means when it comes to the usage, that these two processes must be mutually excluded on the shared resource. If they don't, there will be a deadlock. So precisely where we are at the moment, there are two words that I will quickly mention right here. One is the request scenario. In the request scenario, all these requests are going to the resource manager, which in this case is the operating system. An operating system, after receiving these requests, will allocate, please remember this one, will allocate a resource. So allocation is a logical thing. We understand that. Allocation is logical thing. Just like you want to book a hotel room and the manager of the hotel confirms that they had booked a room for you for a certain day. And that is allocation. But then when it comes to usage, before you actually use the resource, you will have to acquire it. And to acquire it, you have to physically go there and acquire it. And that is what we call acquisition. So allocation and acquisition. These are the two words that you must remember. These are the two words. These are the two words that we must remember. The allocation and acquisition. The allocation and acquisitions are most important. Now remember, as I said, the allocation is a physical thing. Allocation is a logical thing. Acquisition is a physical thing. And in fact, I wish we didn't waste the time at the beginning. But anyway, because this setting is very important. Allocation and acquisition. Allocation of resource and acquisition of resource. Okay? Allocation is done by operating system, which is purely logical. And acquisition is purely physical. In fact, we can think of the same thing in a slightly different way, through an analogy perhaps. As I said, that you want to travel to somewhere and you want to book a hotel. So you give a call to them, and the hotel manager tells you, wait a minute, let me look at my register. So he looks into his register, the hotel register, and then he tells you that, okay, your booking is confirmed. I have booked room number 10 on the third floor for you on that day starting from 12 noon. So you are happy because you know that logically a room number 10, will belong to you after 12 noon on that particular day. So you arrive there on that day and you go straight to room number 10. And you open the door, step in, and you are in conflict with the other guy who hasn't checked out yet. Because you made a prediction. You made an assumption that since it's already past 12, and since the manager has logically given the room to you, logically, that means on papers, it already belongs to you. But you made an assumption about the other guy, the previous night's guy's behavior, because he was supposed to be out by that time. But for some odd reasons, he is still in there. He's a little bit late on his checkout. So two of you end up inside the same room and start a fight. And the resource is blocked. None of you can freely use that resource. Right? This is the classic problem that happens when you go for acquisition, when you transit from allocation state into acquisition state. So in between allocation state and acquisition state, there needs to be something right in here to ensure that this kind of thing never happens. And that is something we studied in an earlier chapter, and we called it IPC, inter-process communication. Remember? Peterson's solution, lock variables, TSL, test and set lock, semaphore, then mutex, all these things we talked about that part. So we must position ourselves very well to know exactly what we're studying. We already finished dealing with this part, IPC. IPC happens to make sure that mutual exclusion condition persists at the time of acquisition. I repeat, IPC was all there, the IPC rules and IPC techniques were all there to ensure that mutual exclusion condition persists during resource acquisition. Is that clear? So let's go back and see how could we solve the problem, this travel related problem. So now that you got a confirmation from the Mr. Manager that room number 10 on the third floor has been booked for you, you arrive there on that very day at the right time, but you don't go straight to room number 10. Although you know it's already 12 o'clock, so logically that room belongs to you at the moment. But still you don't go there. You wait in the lobby. Waiting for what? Waiting for the manager to hand over the key, the door key, to you. Once the manager hands over the door key, then you go upstairs, open the door, and you are absolutely all on your own. You are mutually excluded from whoever had spent the previous night in that room. And the same with that guy. Whenever he checks out, he will have to lock the door and return the key to the manager. And then the manager will hand over the key to you, the new incumbent process, if you think about yourself as a process. So doesn't it sound very familiar to what we studied in IPC? It should, if you have studied it carefully. This is exactly what we did and what we ended up with in IPC, called semaphore combined with a lock that is called mutex lock. Semaphore is a signal with an up. So semaphore up, mutex lock, mutex unlock, semaphore down, and off you go. Remember? So we did it in this zone, allocation and between allocation and acquisition, in fact, before acquisition. We were dealing with that part. Now here, in this deadlock chapter, we'll be dealing in this part. You position yourself very well, so there won't be any conflict. Okay. OS, since OS is the resource manager, and OS is solely responsible, just like the Mr. Colonel, the hotel manager. Okay, the OS is solely responsible for allocating these resources in the proper way. And that allocation is purely logical. So what OS can do to make things possible in such a, to allocate the resources in such a way so that a deadlock can either be prevented or avoided, or even if the deadlock happens, it should be detected and can be recovered from. I repeat, OS, through its logical allocation of resources, will try to ensure as best as it can, although it's not 100% possible, we'll say that, but it will try on its own as best as it can to allocate resources in such a way that it can still detect and recover from a deadlock. It can prevent a deadlock, or at least can avoid a deadlock. So once the allocation is done, as confirmed by OS, then during the acquisition time, we have another layer of security, you might say, to prevent deadlock, and that is IPC, the IPC rules. So both have a role to play, not only the processes, but also the OS. Right? That's it. Or if you can think about it, the OS, maybe OS is a policeman. The policeman, they have set up all these street signs and road signs to guide the travelers in such a way that there won't be any traffic jam. But then that's not all. When you drive a motorbike, so all of us, we have our responsibilities. That is inter-process communication. We need to talk, our vehicles need to talk to each other in a way that not only we follow those rules, but still we stay safe. Okay? By constantly talking to each other. That's it, in whichever way you think. Now let's move in quickly. Conditions of resource deadlock. These are the bunch of things that we are going to study. You see, detection and recovery. First, we will quickly go to deadlock modeling. Why deadlock happens? I already told you the deadlock scenario. The problem is, in the request scenario, multiple resources are being requested by multiple processes. It's absolutely a messy thing. But when it comes to the usage scenario, it's strictly one-on-one. Okay, at any given point of time. A classic example of deadlock, one classic example, is a set of blocked processes holding a resource and waiting to acquire a resource. Something that we already talked about, right, in our IPC, in classic IPC problem. Remember the diner's problem, a round table and the guys sitting around it. Each of them have a shared chopstick. Now, one important question I would like to raise here. So we understand what happens. It all starts with a hold and wait condition. Take care of that. Hold and wait condition. What's an hold and wait condition? It's the first guy who felt hungry. He picked up two chopsticks on either side and started eating. Before he could finish eating, the second guy felt hungry. But for him, there's only one chopstick on his right side is available. So he picked it up and starts waiting. Why waiting? He's not using that chopstick. He is waiting for the other chopsticks because that chopstick is being used by the first guy. He's waiting for the first guy to release that chopstick. Now, this is what we call hold and wait condition. As we repeatedly alert you that hold and wait condition as such is not a deadlock. But something can still be done logically to avoid this situation. But if you don't do anything, if you allow this problem to perpetuate or spread all around the table, then you end up with a condition that we call circular wait condition. Once you reach there, then that is pure deadlock. And that's exactly what we're talking about. Circular wait condition, where each one is holding a resource and asking for a resource, and no one knows who will be the first one. Well, it's absolutely a no-go situation. Okay? Resources. You're already familiar with these two words in another context, but we use them. It's better not to. It's better not to mix them together. Okay. We talked about preemptive algorithms and non-preemptive algorithms, right? But right now, we are talking about preemptible resources and non-preemptible resources. Preemptible resources are the resources, but so they're all the resources. Resources are mostly hardware, as we understand. Okay, the computer resources, and processes are definitely software. So the resources, these resources can be categorized broadly in two groups. One is called preemptible, one is called non-preemptible. So preemptible resource and non-preemptible resource. Yeah. Preemptible resources are the ones that can be taken back by the OS whenever the OS knows that it is blocked. Whenever these preemptible resources get blocked, that OS has the capacity, in its own capacity, can snatch it back from a dead process or a process that has voluntarily blocked it. Whereas the non-preemptible resources are the ones that nothing can be done with those resources. The non-preemptible resources can be snatched back by the process, by the kernel or the OS. The only way to acquire them is you have to wait until the process has voluntarily released the non-preemptible resource. So a process, if it ends up in a deadlock blocking a non-preemptible resource, then expect a fatal deadlock. And you know the word fatal accident, where someone loses his life. Okay, so your system will crash. So fatal deadlocks happen with non-preemptible resources. Yes, that's why I said that don't mix them together. Preemptive algorithm, non-preemptive algorithm, slightly different from preemptible resource and non-preemptible resource. Although somewhere deep down, well, you can see a connection between them. The meaning, of course, they originate from the same word, the root word, preemption. So anyway, you don't have to dig deeper. Preemptible resource, non-preemptible resource. Acquisition. And as just now at the beginning I pointed out, acquisition is a place. It's not only a physical thing where a process is going there to physically acquire the resource, and this is where the deadlocks. And that's where they need to talk to each other. These processes need to have a mechanism to talk to each other, to communicate with each other. And that's exactly what to do, if you still can remember, by using semaphore up. That means give a wake-up call, select the next guy to come over and wait in the lobby, in the enter region, and then set the lock. Mutex lock. Then use the resource, then mutex unlock. That means return the key and give a down call, semaphore down, requesting the kernel to block itself because it has already returned the key. And now the kernel will again, this next one that has already been waiting in the entire region, the lobby, that process will acquire the lock and will put the lock on. And this lock is a kernel level lock. Just like in our example, as we say, there's a door key there, and the door key belongs to whom? Does it belong to you? Does it belong to the guy, the previous night's guy? No, it belongs to the hotel manager. Okay, he's the owner of that room. He's the owner of that key. So just like that, here too, the kernel is the owner of the lock. That's called mutex. Mutex stands for mutual extension. Exclusion, sorry, mutual exclusion. A lock for mutual exclusion. So we already understand that. So we move on because, as we said, we position ourselves very well. We are not going back to the IPC. We are here to talk about what OS does. And what OS does is not in the acquisition level, but the allocation level. So we'll move to that part. So what's a deadlock? A bottleneck. That is what we are looking at right here. It's a bottleneck situation. None of them can be awakened, none of them can release any resource, none of them can, none of the process can run. So that will create a bottleneck and a deadlock. Very important slide, and it must be reminiscent to, for some of you, not reminiscent to what you studied in the beginning of the IPC chapter. You remember we mentioned 4 conditions to avoid race condition, and some of the things mentioned here can be quickly associated with those things, but of course in a different way. But anyway, if you still want to remember these things distinctly, do it. But please remember these 4 conditions, and these are very, very important conditions. Mutual exclusion, we are familiar with that. It's all because of the mutual exclusion, because of that condition, that we get deadlock. It is the factor, it is the request scenario where everything is one and on. But that's the nature of the resources, of the shared resources. That's the way a resource works. After all, it's a machine. Right. You can think of the ATM machine or the same machine, but with 2 interfaces. One guy can stand on the side, one can stand on the back, and one on this side, and one guy stand on this side. If that we could have, then no problem. The 2 guys could easily use the ATM machine at the same point of time. But not just the interface, you have to have the proper internal structure and the mechanism to process 2 things simultaneously. That means 2 CPUs. So having 2 CPUs means 2 different machines anyway, so no problem. Mutual exclusion. It is because of the mutual exclusion that the problem happens. And later we will see when it comes to trying to prevent those things from happening. We will be attacking, literally we will be attacking these 4 conditions. And we already talked about one of these attacks. If you remember, in the last chapter, the very end of that chapter, IO chapter, we talked about spooling. We did spooling because we wanted to prevent mutual exclusion condition to happen, to occur. If you can still remember, I'm not going back there, but that's what we did with the printers, the spooling directory, and daemon. So sometimes next week when I ask you questions, my questions could be a cross-platform question. Cross-platform question means I can easily relate IPC with deadlock. Okay, or with deadlock with a little bit of IO. Because come on, man, all these things are happening inside your OS, inside your computer. So you can't just separate them. Okay, although they are supposed to be separated for the sake of your exam. But anyways, Moving on, so we have the mutual exclusion condition. Then we have the hold and wait condition. We already mentioned the hold and wait condition. And as I said, that hold and wait condition is not exactly a deadlock. But this is the beginning of the problem. If you don't take action there, then you allow it to propagate, then you end up with circular wait condition. And that is a definitive deadlock. And also the third condition, no preemption condition. Unfortunately, we can't do anything about that. We understand there are some resources. In fact, most of the resources inside your computer are non-preemptible resources. So in that case, we really can't do anything. We can't help them. If they are non-preemptible, they are non-preemptible. You can't enforce preemption on a non-preemptible resource. They can't be taken back. So the fact that some of the resources are non-preemptible, that can voluntarily be released by the process currently using them, and the kernel can't do anything to snatch it back. So that very fact is one of the root cause of deadlocks happening. So these four conditions are very important. Please remember them, because when we go to the prevention, as we said, the OS will logically try to do everything possible during the allocation phase to detect and recover from a deadlock, to avoid a deadlock, and to prevent a deadlock. So when it comes to prevention, we basically attack these four conditions that can create a deadlock. Modeling. A wonderful word, deadlock modeling. Wait a minute. Wait, why we need a model? Because just now I said that everything is logical in what we are going to study in this chapter, because everything is being managed by operating system. And everything is associated with allocation. We are not talking about acquisition here anymore. Okay? We are talking about allocation. And allocation is a logical process. Now, if you want to understand that if your allocation is right or wrong, you have to build a model. So keep it simple. Why do we make models? We make models to understand a pattern in anything. Before you purchase a house, you want to see a 3D model of the house, because that will help you to understand the pattern of the design. Okay, if you're not happy with the pattern and the pattern of the design, pattern of the architecture, whatever, a pattern. So if you're not happy with that, you can change it. That's exactly what OS is trying to do by creating a model for the deadlock, to understand a pattern of allocation, resource allocation that leads to deadlock. A pattern of resource allocation that eventually leads to deadlock. And that's what it wants to understand. And the point there is not just that one. There's more than that into it. And what is that? That is that what tool will you use? What tool will you use to do that allocation, to bring that model? You need a tool to understand that pattern. And you understand that whenever there is a pattern recognition, we always go for the best tool that we can think of, and that is a graph. And here too, it won't be any exception, because we will use a tool, and that tool is called resource graph. This resource graph is one of the most important tools. I do ask questions from there, that which tool do we use to model the deadlock? Remember, if I use the word tool, and you understand the difference, the tool. Okay, you use the tool to create a pattern, and from the pattern you can model something. Very simple to remember. Like your Microsoft Excel. What is your Microsoft Excel? Now it's high time you get over the answer that you're probably thinking of. You might say, oh, it's a software. It gives me a solution. Right? Sorry, your Microsoft Excel doesn't give you a solution. It doesn't give you any solution here. That's not true. It helps you to get to your solution. Think about it. It's a tool. So any software that you use, especially there's a Microsoft Office, for example, Office-related software, Excel, for example, it's a tool that helps you to get to the solution by understanding a pattern and analyzing the data. It's a tool for data analysis. If you think about an Excel graph, that's what it is. You use a graph to plot the data points to understand a pattern, whatever it is. The pattern of the sales, okay, a pattern of your profit from the market, from the sales of a particular item over the past 1 year. So you are building a model by using a tool, and the tool is a graph that helps you to build that model. And that's what we are looking at. At this very moment, we are looking at a deadlock model. But the same resource graph will be used later on to predict a deadlock when it comes to avoid. Okay? We will be predicting. But right now, we are trying to detect it. Please don't confuse these two words. Okay? And that's why I love this chapter. They play with the words. Detection and avoidance are two different things. So here we are trying to detect. Over there, little later, in avoidance, we will use the same tool, the same pattern, build a model, but to predict if a deadlock is about to happen or not. Because if you can predict it correctly, you can avoid it. Did you get my point? So let's see what's happening right here in front of us. Well, everything was going fine, no problem. Remember, an arrow pointing from the resource. This is a resource. The R is a resource. The R is a resource, and this is a process. And this is the resource. Okay? An arrow pointing from the resource to the process, that means the process is currently holding that resource. Or you can say the process has already, the resource has already been allocated to the process. Well, I shouldn't use the word holding, but it is more like allocation. So it's already allocated to that process. But when you see the reverse one, that is an arrow coming from the process towards the resource, that signifies, that indicates that that resource is being requested by the process. So there we go. As we say, up to EFG, everything was fine. But the beginning of the problem was from picture 8. The beginning of the problem is picture H, because that is where hold and wait condition starts. That is where the hold and wait condition starts. Okay, so it is there where we should have taken some steps, or we should have done something logical to prevent this thing from happening. But since we didn't take action over there, it went on to create a circular wait. You see, picture J is a circular wait condition. Total deadlock. No one knows how to get out of that. Okay? So that is what we were dealing with. Here's another example. No problem with that, because we could avoid it. by changing the resource allocation pattern. Okay, so that is what we can do. Deadlock modeling, and there we are. Please remember, it is a tool. And I ask this question, and some of you will get this question from me for sure. If you choose Deadlock Chapter, then you will get this question: which tool do we use to model deadlock? So when the students hear the word tool, they'll probably start thinking about a hammer or nail or something like that. No. It is the resource graph. Okay. So make sure you give the right answer. There are some basic facts that you will need to remember for the sake of your exam. If on your graph you see there is no cycle, then there is no deadlock. If there are cycles, if it is one instance per resource type, then deadlock. If multiple instances of resource type, then a possibility of deadlock. Okay, so that is something that we need to understand quickly and remember as well. Very important. Strategies for dealing with deadlocks. Okay, we will stop here. Okay, we have to take your attendance on time. Very interesting. We have Ostrich Algorithm. Okay, we will talk about it in the next class on Monday. So please remind me that we will get started without wasting any time. When I ask you, just quickly send me a message that we will start from the strategies, okay, for dealing with deadlock. Because I really want to finish it on that day, but I just don't want to rush. Maybe we might actually use a little bit of Wednesday as well, but I want to take at least 1 or 2 presentations, get it started on Wednesday, without further delay. And one other thing that, okay, let me go to your attendance sheet, because we lost a little bit of time, but that was all a big mess up, and I have no notion that someone was there. Okay, during your presentation, I will follow this particular chart. I think this is accessible to you as well, because some students told me. You guys can also see it. So you guys should know that it will be the first one or will be the next one. And like Shuang Wang, fortunately or unfortunately, you will be the first one to give the presentation and attend the QA. But don't back out. If you back out, you lose some marks. I may take you later, but you'll never be graded out of 100. Okay, that's why I make it very clear, stay prepared. Now again, you may be prepared, you're right here, some of the number 4 guy and number 5 guy, and you're expecting that you'll be giving the presentation on that day, but it all depends on the previous guys, you see. If you can't manage the time, you might have to wait until the next slide. So whatever it is, I will follow this chart. Is that fair enough? So you will know exactly what is coming up. The last guy, who is that? Walk home, he's very happy, must be smiling. You don't have to worry. It's all because that you will know exactly who will be next. Anyway, let me take your attendance. Wrong one. Not there. Chi Kong. If you're there, if you have a mic problem, send me a message. Vin Phuc. Duc Huang.
Yes.
Luong Ha.
Yes.
Hu Huang.
Yes.
Tan Hum.
Yeah.
Ngọc Phát.
Yes.
Din Min.
Yes.
Quoc Huy.
Yes.
Huy An.
Yes.
Kim Thạc.
Yes.
Nhật Min.
Yes.
Thiện Phúc, Thiện Phúc, Quang Huy,
Yes.
Minh Quang, Duy Bao,
Yes.
Khuây Minh, Liêm Trúc,
Yes.
Quang Hùng.
Yes.
Okay. Okay, well there. Xuan Wang. Hey, Xuan Wang, you always, every day, you send me a message. So how will you give your presentation? If your mic is not working? Have you thought about it? Hmm? What's your master solution for that? Yeah, yes, but my question is, especially to Xuan Huang, because you consistently send me message to give you attendance. So it seems the mic is not working for a fairly long time. So how will you start your presentation? How will you give your presentation? So anyway, for those especially, well, by the way, I mentioned it already there that you have to show your face. You have to use your camera. There's no excuse for that you are giving the presentation. Without camera, without mic, there won't be any presentation. Not necessarily you can do it just like I do, that you use your cell phone and your laptop. You run the presentation from the laptop and you log in through your cell phone, at least for that session. You download the app and log in from the cell phone, and you can use the cell phone mic and webcam. But you have to do it because without that, I will not take it. You will get zero. Because there were cases before where students were sort of cheating, even on cam. Of course, I can't verify that, but I have to give you the benefit of doubt. A girl did it, and later she was caught by her classmates because I couldn't catch her. Because the classmates, and they reported to me, and then she confessed that her sister was dubbing while she was on cam giving lips, just like in the movie. Fantastic. Okay. So, anyways, so please don't do that. On my part, I need to see your face, at least to know that you're giving lips. Anyway, that's all. Stay prepared and don't forget to remind me. We will start from strategies of deadlock. Okay? And Kim Tak, hopefully I have a break time after 2 o'clock. So by the end of today, you will get your lab scope. Don't worry for that. As soon as possible. When? But you are the first one. Xuan Huang, you are the first one. No excuse. I've warned you here. You still have almost 1 week. You must give the presentation on that very day, on Wednesday. Okay, so stay prepared. Do whatever you have to do with the laptop or your cell phone. Get ready, because you will be the first one to give the presentation. If you back out, you lose grades, lose marks. So make sure you understand. All right, that's all. We'll see you again on Monday. Enjoy your weekend. Bye.